Hello everyone. So again welcome to the lecture number 20. So in this lecture we will discuss about another example, that is example number 4. So let's start reading the example. So it is given that two parallel lines L and M. So it is given that there are two parallel lines L and M. So let us draw the two parallel lines. Let's say this is the parallel line L and this is another line M. Okay. So it is given L is parallel to M. This is given, right? Are intersected by a transversal line P. That means P is the transversal line which intersect the two parallel lines L and M. Let's say this is the transversal line P. Is it clear? Okay. So P is the transversal line, L and M are two parallel lines. Now, so that the quadrilateral formed by the bisector of interior angles is a rectangle. Let's read it clearly. So that the quadrilateral formed, that means the quadrilateral that is formed. When the quadrilateral is formed? By drawing the bisector of interior angles. Okay, see, whenever a transversal line intersects any two parallel lines, then tell me how many interior angles are formed? Total 4 interior angles are formed. This is the first interior angle, second interior angle, third interior angle, and fourth interior angle. So total 4 interior angles are formed, and these 4 are exterior angles. So if we draw the bisector of those interior angles, okay, if we draw the angle bisector of those interior angles, so let's draw the angle bisector of each interior angles. Okay. Let's say this is the angle bisector of this angle. Clear? Let's say this is the angle bisector of this angle. As you can see, this angle bisector of this angle and the angle bisector of this angle meet each other at a common point, right? At this point. Suppose this point is O. Clear? Similarly, if we draw the angle bisector of this angle, let's say this is the angle bisector, right? Similarly, if we draw the angle bisector of this angle, let's say this is the angle bisector, then here also you can see this angle bisector and this angle bisector meet each other at a common point. This point, let's say this point is P. Now, whenever I draw the angle bisector of each 4 interior angles, then what you can see? You can see a quadrilateral is formed, isn't it? This is a quadrilateral or not? This one is a quadrilateral or not? Yes, this is a quadrilateral. Now we have to prove that the quadrilateral formed is a rectangle. It is a rectangle. Okay. So now do you understand the question clearly? According to the question, it is given these two lines are two parallel lines. This is the transversal line. Okay. Suppose this transversal line intersects these two lines at 2 points. Suppose this is A point, okay, and this is point B, right? Okay. Suppose this is CB, okay, and this is EF, right? This is the L line, this is the M line. Clearly understood? Next, this angle is bisected by the line OA. This angle is bisected by line the BO. This angle is bisected by line AP, and this angle is bisected line by PB. Now, after bisecting all the interior angles formed, right, they will form a quadrilateral. But it is not sure which type of quadrilateral it is. Only we found that this is a quadrilateral, and we have to prove that this quadrilateral is a rectangle. Okay. So let's write what is given in this question so that you can easily understand it. Okay. So it is given this line L, or you can say CD line. CD is parallel to EF. EF. Okay. And P is the transversal line. And P is the transversal line. Understood? Now, which intersect at A and B, which intersect line L and line M at A and B, which intersect CD and EF at A and B. Right? Next, then tell me how many interangles are formed? 4 interangles are formed. This angle, this angle, this angle, this angle. Here, 4 interior angles are formed. Angles are formed. So name them. This interangle's name is DAB. So DAB angle, comma. This angle is FBA. FBA angle. Understood? Then this angle is EBA. EBA angle, and this angle CAB. Okay, these 4 are interior angles formed. Now OA is the angle bisector of this angle, so you have to also write it. OA is angle bisector of which angle? This angle, angle DAB. Clear? Similarly, OD is angle bisector of this angle FBA. Okay? AP is the angle bisector. AP is angle bisector of this angle CAB. And this one, okay, PB is angle bisector of which angle? This angle EBA. Okay, I have written everything what is given in this question so that you can easily find out which is valid for this proof. Okay, so now again, as you can see, OA angle bisector and OB angle bisector meet each other at O. So you have to also write it. So this is the second, this is the first, right? Then you have to write OA and OB meet each other at O. Similarly, PA and PB meet each other at P. PA and PB meet each other at. Okay, so we have written everything what is given. Now from this given data, what we have to prove? We have to prove that a quadrilateral that is formed AOBP is a quadrilateral. This quadrilateral is a rectangle. Okay, so let us first take a screenshot of it. Then in the next page I will write the proof. Okay, and now let us come for its proof. Okay, so from the given data we have to prove that this quadrilateral formed is a rectangle. So you can write AOBP. We have to prove AOBP quadrilateral. This is quadrilateral is a rectangle. Understood? So let's prove it. So initially it is given that CD line and EF line are two parallel lines. It is given, and this P is the transversal line. Yes or no? Yes. So since CD parallel to EF and P is transversal. Okay, then tell me, this angle and this angle are known as what? They are known as alternate interior angles. If these two are parallel and this is the transversal, then these two are alternate interior. So we can write CAB angle and FBA angle are equal, because we know the alternate pair of angles, alternate interior angles are equal. So CAB angle is equal to FBA angle. Understood? Similarly, this angle and this angle, these two pair of angles are also alternate interior angles and they are also equal. So you can write DAB is equal to EBA. Okay? So you can write DAB angle is equal to EBA angle. Right? You can write the reason that they are alternate interior angles. Okay? Done. Now consider these two angles. CAB. So this angle can be written as this angle plus this angle. Clear? So CAP plus PAB. Okay. So CAP plus PAB. Similarly, FBA angle can be, that means this angle can be written as this angle plus this angle. Okay, so FBO plus OBA. FBO plus OBA. Okay, it is clear. Now already it is given that AP, we are considering this two angle. Okay, not this angle, only consider this two angle. Since it is given that for this angle AP is the angle bisector, it means this angle is equal to this angle. Okay, so in the place of this angle CAP, can we write this angle PAB? Yes, because AP is the angle bisector, right? So in the place of CAP we can write PAB. So PAB plus, again there is also PAB is equal to, for this angle, okay, OB is the angle bisector, so this angle's value is equal to this angle's value, right? So in the place of this angle FBO we can substitute OBA because these two angles or these two half are equal, right? So FBO can be written as OBA plus, again there is another OBA. Is it clear? Next, PAB plus PAB is 2 times of PAB. Okay. Similarly, OBA plus OBA means 2 times of OBA. Okay. So now these two can be cancelled out. If you take this 2 in the right hand side, then these two will be cancelled. Right. So next you will find PAB is equal to OBA. Okay, this is fine. So we have finally found that PAB, that means this angle is equal to OBA. This angle. Okay. Now if we consider PA, okay, and another line BO, right, like this, and AB is a transversal line. AB is a transversal line. So what we have proved here? We have proved that this angle, that means this angle is equal to this angle, isn't it? Here we have proved PAB is equal to OBA, PAB is equal to OBA. We have proved this angle is equal to this angle. Now tell me, if these two are two lines and this is the transversal line, and if these two angles are equal, then tell me these two angles are known as what? They are known as alternate interior angles. And here we have proved that the pair of alternate interior angles are equal. They are equal. Okay. So you can write, but these two are alternate interior angles. Okay. For which two lines? For the line PA and BO. So we can write that PA is parallel to BO. That means this line PA is parallel to this line BO. Do you clear this? Okay. So we can write simply PA is parallel to BO. That means this line BO. Okay. Is it clear now? So we have proved for this quadrilateral, this side is parallel to this side. These two are opposite side. Understood? Now, similar procedure is followed here also. Okay. So here, as we know, DAB angle is equal to EBA angle. Okay. DAB and EBA are equal because they are alternate interior. Now, in the place of DAB, can we write this angle plus this angle? Yes, we can write. So DAO plus OAB. Okay. So DAO plus OAB. Okay. Similarly, in the place of EBA, that means this angle, we can substitute this angle plus this angle. EBP plus PBA. Okay, right? Next, since AO is the angle bisector for the angle this DAB, so this angle is equal to this angle. Okay, so in the place of DAO, we can substitute OAB because these two angles are half. So in the place of DAO, we can substitute this angle OAB. Okay, in the place of DAO, you can substitute OAB. There is another OAB. Okay. Now, for this angle, PB is the angle bisector. That means this angle is equal to this angle. Okay. So in the place of EBP, we can substitute this angle PBA. Right. So in the place of EBP, substitute PBA. There is another PBA. So OAB plus OAB is 2OAB is equal to PBA plus PBA is 2PBA. Now when this two move to the right hand side, now this two will be cancelled out. So finally we have OAB is equal to PBA. So what we have proved here? Here we have proved OAB. That means this angle, see this angle is equal to PBA. That means this angle. Okay, just look at my hand, this angle. So these two angles are equal. Now let us consider the line OA. See here, like this. This is OA. Another line PB. Okay. Then consider AB as a transversal line. Right. Now next. So what we have proved here? We have proved that this angle OAB, see OAB is equal to PBA, this angle. So we have proved this angle is equal to this angle. Now tell me, if we consider OA and PB are two lines and AB is the transversal line, then these two angles are known as alternate interior angles. But we have proved that these two pair of alternate interior angles are equal. Okay. So you can write, but these are what? These are alternate interior angles. Is it clear? So since these two are alternate interior angles and they are also equal, so we can write that these two lines are parallel. As we have considered AO and PB lines, so we can write AO is parallel to PB, right? So we can write AO is parallel to PB. Okay, let's say this is equation 1, and now we have proved this one, equation 2. AO is parallel to PB. This is parallel to this. Okay, now just see the quadrilateral AOBP. In AOBP we have proved AO is parallel to PB. These are two opposite sides and they are also parallel. Similarly, from the equation 1 we have proved AP is parallel to OB. See, AP is parallel to OB. These two are also opposite pair of lines. So here we have proved for this quadrilateral, the pair of opposite sides are parallel. This parallel to this and this parallel to this. It means this quadrilateral is nothing but a parallelogram. Is it clear? So we can write, what we can write? We can write hence from equation 1 and 2, we got, what we got? AOBP is a parallelogram. Okay, understood? Now it becomes a parallelogram. But what is our intention? We have to prove AOBP is a rectangle, not a parallelogram, rectangle. So let's see how we can prove that this parallelogram is nothing but a rectangle. Okay, let's see in the next page. So we have already proved that this quadrilateral AOBP is a parallelogram. Okay, so already we have proved that AOBP is a parallelogram. But we have to prove this quadrilateral is not a parallelogram. No, it is a rectangle. We have to prove this. How can we prove it? Let's see. Since it is given that CD is parallel to EF, okay, and P is the transversal line, then tell me these two angles are known as which type of angles? If these two are parallel line, this is the transversal line, then these two angles are known as which type of angle? They are known as co-interior angles, isn't it? Yes, they are co-interior angles, and we know the sum of two co-interior angles is equal to how much? It is equal to 180 degree. So you can substitute, or you can write CAB plus EBA. This two angle is equal to 180 degree. Okay. So now you can write CAB plus EBA is equal to 180 degree. The reason is that they are co-interior. Okay. So now we will do what? Now we will multiply half to both the sides. Half is multiplied with the left hand side and with the right hand side. Okay. So let's multiply. So half into CAB plus EBA, this is the left hand side, then this half is multiplied with the right hand side. Okay. Now when half is multiplied with this bracket, then we have to use distributive rule. So half is multiplied with this and half is again multiplied with this. This is distributive law. So half of CAB plus half into this, half of EBA is equal to 2 is cancelled with 180, it will give 90 degree. So now we find this plus this is equal to 90 degree. Now half of CAB means what? Half of CAB, this is the total angle. Now half of this angle is what? Is this angle. Why? Because PA is the angle bisector. So this half is equal to this half. So whenever we are going to find the half of the total angle, it means we can write this angle only. Yes or no? Yes. So we can write PAB angle. Okay. In the place of half CAB, we can substitute this half, this angle. Okay, PAB. So we can write PAB plus. Now half of EBA, this is the total angle. Now half of it means we can write this angle because PB is the angle bisector of the total angle. So if we find the half of the total angle, so we can substitute this angle. Okay, PBA. PBA is equal to 90 degree. Done. So finally what we have found? So finally we have found that PAB, that means PAB, this angle, okay, this angle plus PBA, that means this angle is equal to 90 degree. Clear? Next. Next we have to consider the triangle APB. Which triangle? APB triangle. Okay. So here you can write, let us consider the triangle APB. APB. Now, in APB triangle, we know the sum of three angles is 180 degree. So we can write that this angle means PAB. We can write PAB plus this angle means PBA plus this angle APB is equal to 180 degree. We know it now. Already in this equation 3, let's say, already in the equation number 3 we know PAB plus PBA is equal to 90 degree. So in this place we can write 90 degree because we have already proved it. Plus, so this two angle is 90 degree plus what is remaining? This angle is remaining, APB is equal to 180 degree. Is it clear? Next, so APB value is 180 degree minus 90 degree is equal to 90 degree. Now we have found that the value of the angle APB, that means this angle's value is 90 degree. Okay, that is why we have done these things in order to find the value of this angle. Already we have found that this angle plus this angle is 90 degree. This is a triangle, so sum of all the three angles is 180 degree. If these two are 90 degree, then definitely this angle is 90 degree. Done. Now, already we know AOBP is a parallelogram. Yes or no? Yes. And in this parallelogram, this angle is 90 degree. So simply we can write angle P is 90 degree. No problem at all. Either you can write APB or angle P. Clear? Next, if it is 90 degree, then what is the value of this angle? Tell me. These two angles are opposite angle and AOBP is a parallelogram. We know the opposite angles are equal. So what is the value of this angle? This must be 90 degree. So we can write is equal to O. Clear? Next, see, if we consider AOBP is a parallelogram, we know the sum of consecutive angle is 180 degree. Okay, so this angle and this angle are two consecutive angles, or you can say this angle and this angle are two consecutive angles. If this is 90, then what is the value of this angle? It must be 90. Yes or no? Yes. So this is also 90. So we can write is equal to angle B. Understood? Similarly, angle B and angle A, this total angle, are also opposite and it is a parallelogram. We know the pair of opposite angles are equal. If it is 90, then definitely this angle is 90. This angle is 90. So we can write is equal to angle A. So finally what we have proved? We have proved AOBP is a parallelogram in which each angle is 90 degree. Now tell me, if in a quadrilateral, okay, opposite pair of sides are parallel, okay, since they are parallel, that means they are also equal and each angle is 90 degree, then which type of quadrilateral it should be? Definitely it will be a rectangle, because in a rectangle we know the pair of opposite sides are parallel and equal and each angle is 90 degree. And here also we have found for the quadrilateral AOBP, each angle is 90 degree and the pair of opposite sides are parallel and as well as equal. So you can write finally, hence AOBP is a rectangle. Understood? Though the proof of this statement is quite long, but it is not as difficult as you think. Okay, it is very easy. You have to understand all this concept clearly. Then you can find out the result that AOBP is a rectangle. Okay, so now this question has been done.